Hello everyone, and welcome to this short presentation on observability in practice. In this talk, I'm going to walk through how metrics, logs, and traces fit together using OpenTelemetry, the open source standard for collecting and connecting these signals. When systems get large or distributed, it's not enough to know if something is up. We need to know why it's slow or where requests failed. Observability is about asking those types of questions without first changing the code. OpenTelemetry captures four kinds of signals. Traces show the path of a single request across services. Metrics record numerical measurements like latency and error counts. Logs capture discrete events at a point in time. Baggage carries contextual information like user IDs so we can tie signals together. Throughout, I'll show how these pieces combine to give true visibility. Before we talk about how OpenTelemetry captures data, we need to agree on what we measure. Site reliability engineering popularized the four golden signals: latency, traffic, errors, and saturation. Latency measures round-trip time and directly affects user experience. Traffic shows demand, usually requests per second, and helps separate load issues from other causes. Errors track failed requests such as HTTP 500s and timeouts. Saturation indicates how full the system is, CPU, memory, or disk, often a precursor to rising latency. Together, these signals summarize system health: how fast, how busy, how broken, and how stressed. Everything else we build, dashboards and traces, sits on top of them. Now, let's define the core signals. Observability's three pillars are logs, metrics, and traces. Logs are events, exceptions, queries, startups, the line-by-line story. Metrics are measurements over time: CPU, request latency, active users, great for trends, alerting, and dashboards. Traces follow requests through services. Each step is a span that shows where time is actually spent. Together, they're complementary. Logs explain what happened, metrics show how much or how often, and traces show where in the flow it actually occurred. If a user says it's slow, metrics confirm it, traces locate it, and logs explain why. How do traces connect across services? In distributed systems, a single request hops from web app to API to database, so we need a consistent identifier. The W3C trace standard defines the trace parent header that links everything. Each request carries a version, a trace ID for the whole request, a parent ID for the triggering span, and trace flags. The trace ID stays constant end to end. The parent ID identifies the immediate caller. When service A calls service B, it forwards this header so B knows it's part of the same trace. This simple header enables end-to-end tracing in tools like Jaeger or Tempo. Next, the component that brings telemetry together: the OpenTelemetry collector. Think of it as a vendor-neutral pipeline with three distinct stages: receive, process, and export. It receives telemetry from OTel instrumented apps, Prometheus scrapes, or systems like Jaeger. It processes data, batching, adding attributes, sampling, or even filtering to control quality and volume. It exports to one or more destinations such as Jaeger, Prometheus, or a vendor tool. Because it speaks common protocols, you can actually change backends without touching app code. In short, the collector is the observability switchboard. Here's how data flows through the collector. Each signal, traces, metrics, or logs, can have one or more pipelines. Pipelines start with receivers that ingest data, for example Prometheus or OTLP, and data flows through processors where you batch, enrich, drop noise, or transform fields. A fan-out at the end sends the result to one or more exporters: Prometheus for metrics, Jaeger for traces, or multiple backends at once. This design lets you keep a local copy for debug while sending another to the cloud, all without code changes. This receiver-processor-exporter pattern keeps things modular and vendor agnostic. So, to ground this, here's the OpenTelemetry demo. It's a realistic e-commerce microservice app with a front-end proxy, checkout, payment, and fraud detection that communicates over HTTP, gRPC, and queues. Services are written in many languages, things like Java, Python, Go, Node, Kotlin, all showing OTel's polyglot support. Because each service is instrumented, we can actually trace a request end-to-end, record metrics like throughput and latency, and capture logs for each span. The demo generates safe, constant load so you can watch traffic, collect telemetry, and see issues surface in dashboards. The perfect sandbox for practicing observability. Pause and think. Your dashboard shows a P95 latency spike while CPU is flat. What do you inspect next and why? I'll give you 10 seconds. Okay, the best next step is traces. With no CPU increase, a downstream dependency, database, cache, or network is likely the bottleneck here. Exemplars link metrics buckets to specific traces, so you can click from the P95 panel straight into the slow request. In this situation, we pivot from the metrics to traces to see where the slowdown actually occurred. That's connected telemetry in action. Alright, for latency metrics, use Prometheus histograms. Percentiles like P95 and P99 require bucketed data that can aggregate across instances. Histograms provide that by counting observations under defined thresholds. Grafana visualizes bucket densities and percentiles over time, revealing the shape of performance rather than just an average. Averages hide tail pain, percentiles expose it, and better reflect user experience. So when building latency dashboards, prefer histograms to simple averages. They actually tell the truer story here. Next, to connect metrics to traces, use exemplars. An exemplar is a breadcrumb linking a single metric sample, say a spike at 12:07 p.m., to the exact trace that experienced it. In Grafana, white dots on the chart are exemplars. Hovering shows the trace ID and a query with Jaeger action. Clicking opens the full trace for that given request. The panel on the right configures how exemplars are actually linked, typically by trace ID. Instead of guessing why a spike happened, you can actually click into it and inspect the precise request, logs, spans, and all. Okay, now let's actually show you what a trace looks like in Jaeger. The left view shows the search and the span timeline, or waterfall. Each span is an operation such as front end to checkout or checkout to payment. The long bar is often your bottleneck. The right view is the service dependency graph showing who talks to whom and at what volume or latency. Together, the timeline and graph give micro and macro perspectives, from one slow request to the architecture picture, so you can actually pinpoint issues without guesswork. And logs matter too. Historically, they live separate from traces, forcing manual cross-lookups. OpenTelemetry correlates them automatically by attaching trace ID and span ID to logs written inside an active span. With a one-line logging instrumenter .instrument in Python, log entries include that context, so from a trace in Jaeger or Tempo you can jump directly to the relevant logs. Metrics say something's wrong, traces show where, and logs basically explain why. And altogether, they complete the entire picture. Now, where do signals actually go? Many teams pair OTel and Tempo for traces, Loki for logs, and Prometheus for metrics. Tempo stores traces in object storage and looks them up via IDs, which scales very cheaply. Loki indexes labels instead of log text for cost-effective search and tight Grafana integration. And Prometheus scrapes and stores metrics locally and powers percentile dashboards. So, all three speak OpenTelemetry, meaning you can mix, swap, and scale components without actually changing the app code, which is vital for this. We've covered a lot, so let's take a minute to tie everything together. Observability at its core is about being able to ask questions about your system without guessing or changing code first. It's how we move from something's wrong to I know exactly where and why it's happening. We started with the 4 golden signals: latency, traffic, errors, and saturation, all the essential indicators of overall system health. These give you a shared vocabulary to describe what's happening before diving into the details. From there, we explored the 3 pillars of observability, so metrics, logs, and traces. Metrics quantify what's happening, logs record the story behind those numbers, and traces connect the dots across multiple services to show you how a single request flows through your system. And we also looked at the W3C trace context, which keeps distributed systems connected by passing a simple trace ID between services. That's the glue that lets us see a complete end-to-end request instead of isolated parts. From there, we examined the OpenTelemetry collector, the heart of this ecosystem. It receives telemetry from many sources, processes it, and exports it anywhere, so things like Prometheus, Jaeger, Tempo, or Loki, generally giving you total control and vendor flexibility. And we also saw how metrics become more meaningful when collected as histograms, letting us track percentiles like P95 instead of averages that hide user pain. And when latency spikes, we learned to look at exemplars, those tiny breadcrumbs that let us jump straight from a metric to the exact trace that caused the issue. From there, we explored Jaeger, where traces turn into span timelines and service-to-service dependency graphs that reveal both fine-grained and system-level insights. And we didn't stop there. Logs also play a role. By automatically attaching trace and span IDs, OpenTelemetry lets you correlate logs with traces so you can move from what happened to why it happened instantly. And finally, we saw how Tempo, Loki, and Prometheus together form a powerful open source observability stack. Each one focuses on a different signal, but they all speak the same OpenTelemetry language, letting you build a complete system without locking yourself into any vendor. So, if you're just getting started, follow this path. Begin with the golden signals, instrument your code with the W3C trace context, run a collector, export to Prometheus and Jaeger or the Grafana stack, and connect your metrics to your traces with exemplars. That's your blueprint for modern, reliable observability. The bottom line is this: observability isn't just about collecting data, it's about connecting it. When metrics, logs, and traces work together, your system stops being a black box and starts telling its story. And that's how you build software you can trust, debug, and continuously improve.